Now let us see what is parallel aiding. Parallel aiding is nothing but these are the two coils connected parallelly. Aiding, both the dots are placed at the entry level. So we are going to apply KVL for this circuit and we are going to find the parallel aiding combinations equation. So this is the equivalent circuit for this for the circuit. So by applying KVL, when we apply KVL for this parallel combination, we have two loops here. One is A, B, E, F, A, and this is the first loop, and the second loop is A, B, C, D, E, F, A. The outer loop is the second loop. So we are going to apply KVL first for this loop and next for the outer loop, so that we'll get the equations for both L1 and L2. So by applying KVL to the loop A, B, E, F, A, this loop, we will write the equation as V of t minus L1 di1 by dt minus M di2 by dt. So mutual inductance di2 by dt is equal to 0. Since aiding, both L and M will follow the same sign. So V of t is equal to, when all the terms will be in the opposite sign, L1 di1 by dt plus M di2 by dt is equal to 1. This is the first equation where we got it for this loop. So now we are going to apply KVL for this loop. So by applying KVL for this loop, we are going to write the equation as V of t L2 di2 by dt minus M di1 by dt. So for writing KVL, V of t is equal to L2 di2 by dt. So opposite sign M di1 by dt. From equation 1 and 2, we have got equations which has both the currents I1 and I2. So what we are going to do next is we are going to apply Laplace transform for these two equations. For equation 1, when we apply Laplace transform, V of t can be written as Vs L1 S I1 of S plus M S I2 of S. So we have written our equation like this. For equation 1, we have got our Laplace transform equation. By applying Laplace transform, we got this equation. For equation 2, similarly we'll write V of S L2 S I2 of S plus M S I1 of S. So after getting these two equations, we'll write it in a matrix form so that it will be easy to find the currents I1 and I2 using Cramer's rule. So we'll write it in a matrix form. For I1 of S is LSL1, I2 of S is MS and SL2, I1, I2, and what is the right hand side is V of S has been written here. By taking determinant for this, just multiplying all these things, S square L1 L2, by multiplying this minus by multiplying this, I am taking S square as common, so I got it as L1 L2 minus M square. So now to get del I1, I am going to apply this right hand side V voltage in first I1 part. So I am applying here. So I am getting my equation like this. So I got my del I1 of S is S into Vs L2 minus M when I am multiplying this. Similarly, when I apply my right hand side to my I2, I got my equation as, by multiplying this minus multiplying this, by taking V of S and S as common, I got L1. Here I got L2 minus M. Here I got L1 minus M. So this is how I got my del I1 and del I2. Now I am going to find my current by Cramer's rule. I1 can be obtained by using Cramer's rule, del I1 by del. So from these equations, I am getting my I1 as, so by Cramer's rule, just S and S square will get cancelled. So I got my equation like this. Similarly, for I2, I would have got my equation like this. I2. So whatever current I have got is my loop currents I1 and I2. But I want the whole current I. To get my I, what I have to, my current has been divided here as I1 and I2. I have got this I1 of S and I2 of S, but I don't know what is the value of I. To obtain the I, I'm going to apply KCL at this node B. So by writing KCL equation at node B, I is entry. So I minus I1 minus I2 is equal to 0. So I minus I1 minus I2 is equal to 0. Therefore, I is equal to I1 plus I2. So by applying Laplace transform for this equation, I can be written as I of S and I1 can be written as I1 of S plus I2 of S. So I'm going to apply my I1 of S and I2 of S in this equation, which I have got it in my previous method. So by seeing this equation, I can see that V of S and S is taken as common and all the other terms has been written as L2 minus M plus L1 minus M. Denominator is going to be the common one. So from this, I can see here L1 plus L2 minus 2M. So I have got my I of S as this equation. So from this, I am going to obtain my V of S. So S into I of S, L1, L2 minus M square. Numerator has came to the denominator section and denominator has come to the numerator. So I got my equation, final equation for my loop figure 1. So for my equivalent circuit, if I apply, it is going to be V of T Leq di by dt. Similarly, how we have obtained in our series aiding and series opposition. But to take Laplace transform for this equation, it can be written as V of S Leq S I of S. By equating these two equations, what happens? We are going to get our Leq, right hand side of these two equations. So when I'm equating these two equations, S I of S Leq is equals to S I of S, and my I of S and I of S, S I of S, S I of S is going to get cancelled. So Leq is equal to L1 L2 minus M square divided by L1 plus L2 minus 2M. So this is how I got my parallel aiding methods equation. Now I am going to see how we are going to handle parallel opposition connection. For parallel opposition connection, two coils are connected parallelly where the dots are placed one at the entry level and one at the leaving point. So this follows the parallel opposing method. For this equation, similar to my parallel aiding, I am going to apply KVL for A, B, E, F, A. So when I apply KVL for A, B, E, F, A, V of t is equal to L d I1 by dt plus M d I2 by dt. How I got my pluses? If one is L and one is at the entry, one is at the leaving, by dot rule, both L and M will have opposite signs. So if L, according to KVL current direction, if this is plus and this is minus, my L will get minus sign. So my M will get a plus sign. So from this equation, I am going to find my V of t is equal to L1 di1 by dt minus M di2 by dt. Similarly, for my outer loop A, B, C, D, E, F, A, this loop I am going to obtain my KVL. So I can write it as V of t minus L2 di2 by d1. Since minus L2, I am going to write it as plus M di1 by dt is equal to 0. From this, I am going to obtain V of t is equal to L2 di2 by dt minus M di1 by dt. So by I have got, similar to my parallel aiding, I will get my I1 and I2 from these two equations, solving these two equations. But I will, to find my total I have to apply KCL at node B. So if by applying KCL at node B, I will get my equation as I1 I minus I1, entry leaving, so I can be written as I I1 plus I2. So by taking Laplace transform for all these three equations which I have obtained, I can write my equation like this. This is similar to the one which we have got in our uh, series aiding parallel aiding method. So the same way, if I do the procedure of taking determinant value I of s, I1 of s, I2 of s, and if I get my I1 and I2, and after finding solving those two equations, I'll get my V of s similar to that method. So only thing is, there I would have, in aiding method I would have got it as minus. Now I will get it as plus if I solve. So this is the equation which I've got for the figure 1. So for figure 2, if I apply KVL, V of t is equals to LEQ by dt, by taking Laplace transform, I would have got my equation like this. So now I'm going to equate these two methods to find my LEQ for parallel opposition. So if I equate these two equations which I obtained, I will get my LEQ is equal to my SI of S will get cancelled. So LEQ is equal to L1 L2 minus M square divided by L1 plus L2 plus 2M. So for parallel opposition, I have got my equation. So this is the comparison for parallel aiding and parallel opposition. For parallel aiding, I would have got here as minus 2. For parallel opposition, I will have got here as plus 2. So these are the last two methods of combination of coupled circuits. So we have seen all four combinations of coupled circuits. One is series aiding, second one is series opposition, third one is parallel aiding and parallel opposition. Now let us discuss some problems based upon the coupled circuits. The first problem statement states that two identical coupled coils in series has an equivalent inductance values of states that LEQ values of first LEQ value and second LEQ value. Find the values of L1 self-inductances of the coil L1, L2 and mutual inductance of the coil and coefficient of coupling K. So we have got two series, means it shows that series aiding and series equivalent equation values. So my series aiding equation is L1 plus L2 plus 2M. The value given here is 0.084. For series opposition, L1 plus L2 minus 2M, and the value given in the question is 0.0354. So I have taken this as two equations. By equating these two equations 1 minus 2, I have got this L1 and L2 will get cancelled. L1 and L1 will get cancelled, 1 minus 2, L2 and L2 will get cancelled. So this will be 2M plus 2M will be 4M, and this minus this will be 0.049. So my M value is going to be this divided by 4. So I have got my M value as 0.01225 Henry. So I have got my one of the value mutual inductance answer. I have got it. Now I have to find my self-inductances of the coil L1, L2 and my coefficient of K. So from equation 1, my L1, L2 is equal to this minus 2M value, 2 into my M value I am substituting here. I've got my value of L1 and L2, L1 plus L2 as 0.0595. Since the question says the two coils are identical, that is L1 is equal to L2, so this divided by 2 is equal to L1 by L2. L1 is equal to L2 is equal to 0.02975. So I have got my self-inductances L1 and L2. Now I have to find my last parameter, coefficient of coupling. The coefficient of coupling K, the formula for that is M divided by root of L1 into L2. I have got my M value, I have got my L1 value and L2 value. If I substitute all the values in this way, I have got my K value as 0.41176 for this problem. So I've got all my answers: mutual inductance L1, L2, and then my K, and I have completed this problem. Now let us see the second problem. The problem statement says that for the given circuit constants, find mutual inductance. That is the first question. To find M, find the equivalent inductances for all the combinations. Equivalent inductances means LEQ. For all the combinations means we have only 4 combinations. So for four formulas, we have to find LEQs if they have given the L1 value, L2 value, and coefficient of coupling K value. So to find the first one, mutual inductance, M is equal to K into root of L1 into L2. K value is 0.5, L1 value is 0.02, and L2 value is 0.01. So when we substitute it, we have got my M value as 7.07 into 10 power minus 3 Henry. So this is my first, I have answered my first question, mutual inductance. Now I have to answer my second question. Find the equivalent inductance for all the combinations. We have, as I said earlier, we have only 4 combinations. First, we'll do all the 4 combinations. This is the first combination, series aiding. For series aiding, a formula for LEQ is equal to L1 plus L2 plus 2M. L1 value plus L2 value plus 2 into M value, which we have obtained. So if we substitute all these things for series aiding, I have got my answer as LEQ is equal to 0.044H. For series supposition, LEQ is equal to L1 plus L2 minus 2M. So minus 2 into my M value, I have got my answer as LEQ is equal to 0.016 Henry. For parallel aiding, LEQ, the formula is equal to L1 L2 minus M square divided by L1 plus L2 minus 2M. So LEQ is equal to 9.4 mH. So I have to substitute my values like this. I have my L1 value is 0.02 into L2 value is 0.01 minus M square value 7.07 into 10 power minus 3 the whole square divided by, again my L1 value denominator is this one, L1 plus L2 0.016. So if I substitute this, I have got my answer as 9.4 microhenry. For parallel opposition, similarly I have taken my equation and I have substituted all my values, and I have got my answer as LEQ is equals to 3.41 microhenry. So I have answered my all 4 combinations now: series aiding, series opposition, parallel aiding, and parallel opposition in my second problem from my second problem's statement. So let's see what is the third problem. The third problem statement says that find the mutual reactance XM in the coupled circuit shown. So they have asked us to find not the mutual inductance value, they have asked us to find a mutual reactance XM if the average power of 8 ohm resistor is 100 watts. So average power of 8 ohm resistor is 100 watts. What is the mutual reactance value? That is the question being asked. So we have to find the individually what is the current inside this, what is the current inside this, and by Cramer's rule we have to find current I1 and I2, and then we have to substitute for this 8 ohm resistor. So by applying KVL to this loop, first loop, voltage is 100 angle 0 minus 5I1 minus J5I1 and minus JXM I2. Since both the dots are the current entry, so therefore for L and M follows the same sign. So L sign will be M sign, so minus. So I can rewrite this equation as by keeping the voltage in the right hand side, all the other terms in the left hand side, 5I1 plus J xm I2 plus j5 I1. So by taking I1 as common, 5 plus j5 can be written here plus jxm I2, and this will be my first equation for the first loop. When I apply KVL for my second loop, when my current direction is in this way, so minus 8 I2 minus j12 I2 minus jxm I1 is equal to 0. I can write it in this way. From this equation, by taking I2 as common, minus of 8 plus j12, I am writing it here, minus jxm I1 is equal to 0. So I have got my first and second equation from the first loop and second loop. So from this I am going to find my I1 and I2. So I am going to write my matrix from the equations 5 plus j5 jxm minus 8 of plus j12 into I1 and I2. My right hand side is 100 angle 0 and 0. From here I am going to find the determinant value. Determinant value, if I multiply this into this minus this into this, I have written here this into a 5 plus j5 into a 8 plus j12 minus of jxm into minus plus jxm. So while substituting entire value in the calculator, I got my equation as 20 minus 100j minus xm square. This is my determinant value which I have obtained. So by Cramer's rule, I am going to find my I1 and I2. So substitute this right hand side voltage value from I1 here to find I1 here, and to find I2 here, I am going to substitute. First, I am going to find my I1. So I am substituting 100 angle 0, which I can take it as 100 and 0. Substituting this 100 into this value minus j into 0. So again my equation goes as minus 800 plus of minus 1200j, which can be written as del I1 minus 800 minus 1200j. Similarly, to find I2, I am going to apply this in my I2 side, and I have got my I2. So from Cramer's rule, I1 is equal to del I1 by del. So from this I have got my equation like this for I1, and for I2, del I2 by del I2 value, whatever I have got as del I2 by my determinant value, I have got my both the currents I1 and I2. Now, as the question statement says, the average power in 8 ohm resistor is 100 watts. So what is the formula for power is I square R is equal to 100 watts. For 8 ohm resistor value is 8, and the current through that 8 ohm resistor is I2 square. So I am going to write my I2 term here, value here, whole square into 8 is equal to 100. Next thing is, what I am doing is I am taking the square value of this, and I am writing it as a plus b the whole square into this value. And next I am going to multiply my 8 here, and I have written my equation like this. So the 10,000 into 8, I have got my 80,000 xm square here. Now I am going to cross multiply this equation. By cross multiplying, keeping this here, 100 into this value has gone up here like this. So for 100 and this 0 0 will get cancelled. So I can get my xm square. I am writing this equation as xm square, the whole square can be written as xm power 4, 20 square a plus b the whole square, a square plus b square plus 2ab. I have written it here like this, a square plus b square plus 2ab plus 100 square is 10,000, and here from here I am writing it as minus 800 xm square. Now by assuming xm square as x, we can write this equation as x square. So square as x means x square plus 400 minus 40x plus 10,000 minus 800x. Rewrite this equation by adding x square 840x plus 10,400 is equal to 0. by solving the equation we get in calculator, we have got the values as x is equal to 827.43 or x is equal to 12.569. So now we'll assume the smallest value of x. So x is considered as 12.567, that is x is equal to, here actually x is equal to xm square 12.567. So xm is equal to 3.545 ohms. This is the answer. Mutual reactance. This is the answer. We have obtained mutual reactance for the circuit.